So A hat X plus Y is equal to this guy plus this guy. But what is this? This is just it is A hat X. And what is this one? Well, this is just A hat of Y. So we are done. Similarly, A hat of lambda X. Well, what is this? This is just summation F J star lambda X Dj. But again, since Fj is linear, I can take lambda out. And actually, I can take lambda outside the summation. But what is this? This is just lambda times A hat X. So A hat is linear. Okay.
Then you prove that A hat is a linear map from B to B. A hat is just belongs to the vector of B.
No. A hat is a homomorphism from B to B. B to R cell dual vector. Okay. Tamam. Şimdi isterseniz birkaç tane örnek yapalım. Let me do a couple examples. Okay, so let's say B is equal to R3, and we have okay, let me choose okay, just two vectors. F and V, değil mi? So we have this evet, sadece iki tane alalım. Yani E'nin şu V tensor. Oh, okay. V is here. F is here. This type. Okay. It's happy. Yeah. Okay. Öyle yazdık. Evet. Şimdi A hat of X ne olacak? A hat of X F star X B olacak. Bir tane sayısal örnek verelim. Mesela let's take B to be a vector in R3. So let's say 3 plus 1 şöyle yapayım. Yani mesela şu olsun. 2, 3, 1 olsun. F star da F star bir tane linear map. Hangi linear map olsun bu? Mesela bu linear map şey olsun. F star. 2 tane E1 star eksi 3 tane E2 star artı E3 star. E1, E2, E3 de şeyler. EI dediğim şey standart basis elemanı. Yani E1 1 0 0, E2 0 1 0, E3 0 0 1. Dolayısıyla E1 star ne yapacak? E1 star maps this to 1, maps this one to 0, this one to 0, right? So E1 or ER star J is just data IJ. Okay, now let's write a head for this V and F. Okay. Take any x, x is in V. So x has coordinates, let's say A, B, C, right? It's a 3 by 1 vector. And this is what? This is just A times E1, B times E2, starting with the left, minus U supposed to put, plus B times 0, 1, 0, plus C times 0, 0, 1. Right? Yes, so a head of X then is that F star at X and then B. What is F star B? Ya da direkt şöyle yapalım. F star B'yi bir hesaplayayım. F star X. Now F star is just 2E1 star minus 3E2 star plus E3 star evaluated on X. X is the A E1 plus B E2 plus C E3. Well, what is this? E1. So I will apply all these terms to this vector one by one. This co-vector evaluated on this will give me what? E1 star will be this guy and gives me 1. On this one it will give 0. On this one it will give us 0. So this is just 2A. This will give me 3B and this will give me just C. So F star at X, if X is this vector, is just 2A minus 3B plus C. So, okay. All right, so any head X or any head, let's say A, ya da şöyle A head A, B, C is what? This was X star at A, B, C times D, right? Okay. We computed this. What is this? This is a scalar. It is 2A minus 3B plus 2 times the vector D. D is what? 2, 3, 1. 2, 3 minus 1. So the value of this gadget is just this constant times this gadget. Okay. A head is a linear map from R2 plus 1 into R2 plus 1. And if you want, we can write down its matrix representation. Aslında matrix representation zaten bunun bariz oldu değil mi? AB'ti şuna uyguladığımız zaman A, B, G'ye ne elde ettik? Kafam karıştı. Şöyle. Tek tek hesaplıyorum. Mesela şu bazda beta bazını E1, E2, E3 alayım. Let's write down the main representation of a head in this space. So I need to compute a head of E1. What is a head of E1? Well, this is a head of 1, 0, 0. So A is 1, the others are 0. So what is this? This is just 2 times, right? 2, 3, 1. So A head main representation in the basis will be what? First row will be what? This is just 4, 6, 2. In other words, this is just 4 times E1, 6 times E2, and 2 times E3. So we get 4, 6, and 2. And then I repeat the same with A2. So a head of 0, 1, 0, 0, 1, 0 will give me what? 2, 3. Şurası da biliyor musun? Tamam. Şurası da eksi 2. Şöyle olacak. Tamam. 0, 1, 0'ın görüntüsü ne? 0, 1, 0, eksi 3. Değil mi? The value of this is just minus 3 times 2, 3 minus 1. So it is just minus 6, minus 9 plus 3. So minus 6, minus 9 plus 3. And what about L3? L3 0, 0, 1. Sadece 1 değil mi? 2, 3 minus 1, 2, 3 minus 1. So 2, 3 minus 1. Tamam mı? So one can represent a linear map by just tensors. Right? Tabii yani size şu exercise vereyim. Exercise. About for the tensor A şu tensor için yapalım. Ve bir F1 star plus B2 F2 star. Evet. B1 işte şöyle. 3, 2, 0. Belki 0, 3. F1 start B1 star olsun. F2 star'da E2 star yani E3 star. Şunu yapabilirsiniz tabii. Yani aynı yukarıda yaptığımı. So you may just repeat what I have done for this one and for this one and then add the results. Okay? Or you can just do it in one step. Yani ben bir tane böyle tensör için yaptım. 2 tane olunca ayrı ayrı topluyorsun. Ben şey yaptım ya işte. Ve tensör edeceğim. Ha aynen. Yine şey yapıyorsun, işte basic elemanlarda isim birden hesapla. Okey. Şimdi önemli şu the map from ne demiştik? İşte şey the yani bu bayağı ne? Evet. Evet neydi? Okay. Eğitim olduğunu söyledik. Bize kanonik algebra. And I will not, deal with the proof of this one. Once you understand what is going on, once you get used to this operation, this will be clear. I showed you one example where we were given a tensor. I wrote down the linear map. Now let's do the other way around. Let's take a linear map and write it as a tensor. Okay, so let's do one example. Right. So we have this theorem. Now let's do it the other way around. Okay. So first is the linear A hat from R P1 into R P1 given by şöyle olsun. A hat X, Y, Z is just şöyle yapayım. Matris gösterimi yapın. 2, 3, eksi 1, 0, 4, 5, eksi 3, 7 ve 2. X, Y, Z. Okay? So it's given by this matrix representation. Right as using patterns. Şöyle yapacağız. Okay. Consider this basis beta E1, E2, E3 again, and this is basis for R3 for R1 and E1 star, E2 star, E2 star for R31 star view. As usual, EI star evaluated on EG is equal to delta I. Okay. All right. Şimdi bakalım nasıl yapacağız bunu. Okay. What is a hat E1? A hat E1, actually, I can compute it like this, 1, 0, 0, and so on. But I don't need to do this because I am already given the matrix representation of this in the canonical basis. So it will be just this column, right? It is just 2, 3, minus 2, 0, 2, 0 minus 1, 2, 0 minus 3, sorry. So this is just 2 times E1 minus 3 times E3, right? So when a head eats this guy, it gives me this. What should be the corresponding element in the tensor? So if it eats this guy, it should give me this gadget. So I can just write this. I will get this gadget when my covector eats this guy. Bunu yiyen nedir? Yediği zaman hani sıfırdan farklı bir şey veren E1 star, değil mi? So take this vector and multiply with this covector. This is not correct way of writing it. Of course, it should be written like this, right? This is the this is how we take product. So when you plug E1 to this, E1 star will eat E1. It will give me 1. So 1 times this vector. It is this one. Okay. Plus a net E2. What is this? This is the second row. 3, 4, 7. 3, 4, 7. So it is just 3 times E1, 4 times E2, 7 times E3. So 3 E1 plus 4 E2 plus 7 E3. Answer E2 star. Right? When you plug E2 star here, it will give you 1 and you will get this one. And this one will give you nothing because this one on E2 is 0. Değil mi? Yani bunu eklemek bunu da bozmuyor. Çünkü bu E1'i yiyor, bu E2'yi yiyor ve birbirlerinin yediklerini yemiyorlar. Değil mi? O yüzden de karışık. And the last one, we had this, the third column, minus 1, 5, and 2. So this is just minus E1 plus 5 E2 plus 2 E3. Bu arada bayağı sınava yönelik işte şey yapıyoruz değil mi? Matrix representation. şey yine. Başka bir soracağım ki. Answer with three star. So that's my A. Okay. When you use this tensor, so this is my D1, okay? D1 tensor E1 star plus D2 tensor E2 star plus D3 tensor E3 star. If you plug E1 star here, this will give me 0. This will give me 0. Only this will give me 1. So I will just get D1, which is D1 is this vector. D2 is this vector. And D3 is this. Okay. So the matrix, sorry, the tensor representation of that gadget is just this. Tamam mı? Şimdi sihir gibi gözükecek bir şey yapacağım. Okay. Another example. Okay, rotation is in R2. So let's take this, and my linear map is the rotation, let's say, take a radius counterclockwise. So whenever you give me a vector, I will rotate it, take a radius counterclockwise. Okay? This is my what? Linear map. So A hat B is what? A hat B is rotating counterclockwise. Counterclockwise. Not five, theta radius. Tamam mı? Bunu tensörlerle nasıl yazalım? Now, if I give this vector E1, 1, 0, this will be moved to this vector. What are the coordinates of this point? Theta'da kadar döndürdüğümüze göre cos theta, sin theta. So, A hat E1 is just cosine theta E1 plus sin theta E2, right? Ya da aslında bunlara hiç girmeden şöyle de yazabilirim. Tensör olarak. Neyse, şöyle. E'nin E2'yu ne yapacak? If I have this E2, then this will be theta. What are the coordinates here? Sinüs kosinüs yer değiştirecek. X koordinatı negatif olacağına göre minus sin theta, cos theta, right? So it is just minus sin theta E1 plus cos theta E2. This gives me actually the linear map, but I could just write it as follows. The tensor would be the following. When I fit E1, I obtain this vector. So buna ne diyeyim? Şuna şey diyeyim. Neyi de kullandık. U1 diyeyim. Buna da U2 diyeyim. O halde o zaman şöyle yazabilirim. E1'i yiyince bana ne veriyor? U1'i. E2 yiyince ne veriyor? U2. So that means like, so if you know the following, if E1 is mapped to U1 theta and E2 is mapped to U2, then the rotation just this tensor. E1 is mapped to U1, E2 is mapped to U2. Okay. Reflection'ı nasıl yazarız? Better? Söyleyeceğim. Another. Suppose we would like to consider the reflection with respect to a line, okay, like this. Some line. And this line, let's say, has this vector, no, vector, B olsun. Bu vektöre göre reflection almak istiyorum. Tamam mı? Nasıl ifade edilir reflection? Bu, let me choose a direction which is perpendicular to this one. Let's say this is U and this is 90 degrees. Okay. So reflector from R2 to R2, ya da evet, R2'dan R2'ya diyeyim. Reflection with respect to the line L. V nerede durur? The vector V is mapped to right by this reflection
itself.
to itself, right? Because it's already in the mirror. Right? So this is just mapped to itself. What about this one? Minus U, right? It's just mapped to this one. And UV is a basis, right? UV is a basis for Q. If you want, we can write matrix representation of this R in this spaces. Evet, nasıl? U'nun görüntüsü neydi? U is mapped to minus U. So it is minus 1, 0. And V is mapped to so 0, 1. It is this one. Right? So then reflection will be what? Is a as a tensor, we can write it nasıl yaparız? R ne yapıyor? B'yi yerinde bırakıyor. So B is mapped to B. So B is mapped to B. B'yi koyduğum zaman B çıkıyor. Değil mi? U'yu ne yapıyor? Minus U'ya gidiyor. Yani minus U. Tamam mı? U, when you plug this guy U, you get U, well, minus U. When you plug B, you get B. It is the reflection. This is the reflection with respect to what? With respect to the line containing the vector V. Tamam mı? So, representing linear maps via tensors has, this kind of advantages. You can write them really easy. Of course, you have to choose the basis and so on again, but